In this video, we are going to learn how to find the inverse function. Basically, f of x is the y value, and f inverse x, that -1, is not taken as a f of -1 power. It's just a notation. That f of -1, or it's not the -1, sorry about that, it's just for lecture part. The f inverse x is also another y. So basically, the left side is the regular function y, and when we switch the x and y, it gets inversed, and there's another y. Let's have the example. What we do is find f inverse of x, which is another y, or the inverse y. We change the f of x notation as y. Next, what we do is switch x and switch y. X takes the position of y, and y takes the position of x, and that is inversed. So this x comes over here. The switch y is the f inverse of x. This x takes place of the y, and the y takes place of the x. I have color coded it. It's already inversed. All we have to do is isolate the y. So simple. Switch the x and y, isolate the y. That's it. Now what we have to do is the isolation. Now when we have y on the right side, I can keep y on the right side, but since the equation is too small, we switch the entire left and the entire right. We don't have to do anything. No change of sign, nothing. Just the value on the right goes to the value of the left, and the value on the left goes to the value on the right. Everything remains same. Now, isolation of the y, what we have to do is move the -3 to the right side. -3 will become +3, which is the same as add 3 on both sides. Now, to isolate the left side, we have to divide this side by 4, and we have to divide the entire right-hand side by 4. So y equals x plus 3 divided by 4. It's done. So the f inverse x is x plus 3 divided by 4. And we are done. Now it's another example. Function of x equals x minus 2 whole square plus 4. Find the f inverse x. All we do is, for the regular function, instead of f of x, we just write it y equals to the function. Next step, switch the x and y, isolate y, and we are done. So we will switch the x and y. X will take the position of y, and y will take the position of x. Everything remains same as is, and the switched y will be the f inverse of x. So the x and y is switched, and we color code the y as the red y. As long as we isolate the y, the value that will turn up is going to be the f inverse of x. So same thing, we switch the entire left side and right side. We don't have to do anything. Keeping y on the left is easy. Switching the left side and the right side, do nothing. No positive, no negative, nothing changes. Now once this is done, we have to we have to get rid of the 4 from the left side first. So it's it's y minus 2 whole square. The x moves to the right side, the 4 moves to the right side. Sorry about that. The positive 4 moves to the right, becomes -4. Now we have to get rid of the power first. Then we will isolate the y by taking care of the -2. To isolate that, we have to square root the left side. Is a power of 2, so second power of root square root is the same. And we have to do the same thing on the right hand side. That will cancel the power. So the left side will be just y minus 2, and the right side will be square root of x minus 4. Now we have to get rid of the 2 from the left side, add 2 on both sides, or move the 2 on the other side and make it positive. So the 2 moves to the right hand side and becomes +2. It's done. This value is the f inverse of x. So f inverse x is square root of x minus 4 plus the 2. And we are done. Another example of f of x equals square root of x plus 9 minus 12. Find the f inverse of x. Same thing, we rewrite the function as y equals to the same value. We will switch the x and y. Inverse is done. And to show the value, all we have to do is isolate the inverse y. So we keep the space blank. We are not writing the x, keeping the space blank for y. Copy the entire value as is. These two places will be switch. X and y, they will switch their places. And the switch y is the inverse function. So y position is taken place by the x, and the x position is taken place by the y. It's done. All we have to do is isolate it. So we switch the left side and right side. All of the left side, all of the right side is gets switched. We have to do nothing. No change of sign. Actually, when we move a independent value from left to right, we switch the sign. If we change the enter left and the enter right, we just have to do nothing. So square root of y plus 9 minus 12 equals x. Get rid of the 12 from the left side. So the 12 moves to the right. It becomes negative 12, becomes positive 12. Now we have to get rid of that square root from the left side. Then we will take care of the 9. To do that, we have to raise the all left side by a power of 2. And we have to do the same thing on the right side as well. That will cancel this square root on the left side. So the left side is going to be simply y plus 9 equals x plus 12, everything to the power of 2. Move the 9 from left to 9, the 9 will become negative 9. Positive 9 is going to become negative 9. Now, when we have a negative 9, we have to watch that 9 is a squareable number, and we have learned it before. Difference of 2 squared, it gets simplified by using the formula of difference of 2 squared. We have a x plus 12, everything squared, minus the 9, but we can write the 9 as a power of 3. So it's going to be the difference of 2 squares. X plus 12 remains as x plus 12. The 9 is written as 3 to the power of 2. Now the simplified portion will be value of the parentheses gets added times the value gets subtracted. So it's going to be the green value plus the blue the green plus the blue times the green subtract the blue. So it's going to be x plus 12 plus the 3. And the other one is x plus 12 minus the 3. Now this gets simplified as 12 plus 3 is 15, so it's x plus 15. And the other one is 12 minus 3 is 9, and it's x plus 9. And that's the inverse y. So finally, f inverse x is x plus 15 times x plus 9. And we are done. We have a different example on this video. We can't switch the x and y. First of all, we replace the function of x as the y and copy the rest of the function. But if we switch and it's 2 x's, we can switch one x with one y. So what we do is we separate it. It's something like if we have 5 minus 3, just giving an example, divided by 7. As long as the denominator is same, we can write it as a common denominator and separate the value. So we separate the x minus 5 as x over 2x minus 5 over 2x, taking the same denominator. Now that helps us to simplify. The x on the top, the x on the bottom, they get cancelled. Finally, we are having y equals 1/2 minus 5 over 2x. So after simplification, now we have the x on the right side and the x on the left side. Now we can make the switch. So we get prepared for the switch, and the switch y is going to be the inverse y. So the place of x is blank, the place of y is blank. Instead of y, we just write the x. Instead of x, we just put the y. Switched, done. All we have to do is simplification. This simplification will take little time because of the fraction. So this time we are keeping the y on the right hand side. Usually previously we switched the left and right, we just keep the y on the right hand side. So first thing is first, we have a common denominator of 2 on the left side, on the right hand side. We have to get rid of it. To do that, we need to multiply every term by 2 because of this 2. This 2 is going to cancel the 2 on this side, cancel the 2 on that side, on the right side, and is going to be simplified as 2x equals just 1 minus 5 over y. Now, to isolate y, the 1 should be moving to the left side, and the 1 will get negative. And we have a negative value with the 5 over y on the right hand side. Now, the next thing is we have to multiply both sides by negative because we will isolate y. Y should not be attached with a negative. So multiplying both sides by a negative is negative of this value. We put the value in the parentheses, and we know the value is divided by 1. We are just using algebra because we have a fraction on the right side as well. And the right side value is just positive 5 over y. Now, there are cross multiplication processes, but all we can do is if I flip the right side, something like if 2 over 3 is 2 over 3, if we flip the left and right, the value changes, but they remain same. So flipping the right side and flipping the left side, maybe the value is changed, but the left side and right side remains to be same. So what we do is flip the left side and flip the right side. So it's 1 over 2x minus 1, and it's negative. And the right side is y over 5, that was positive. Now we just have to get rid of the 5 from the right side. Y will be isolated. To do that, we need to multiply the right side by 5. And we have to do the same thing on the left side. So 5, the denominator is cancelled by multiplying the 5 on multiplying the right side by 5 and doing the same thing on the left side. The left side simplified as 5 on the top divided by 2x minus x. It was negative. And the right side is just isolated y. Everything is done. So f inverse x is just the simplified value, which is negative 5 over 2x minus 1. And we are done. This example is different. It's not going to be equation. When we have an equation of function of x, we select the x and y is decided. So we don't need to know what was the function, but as we put x value, the corresponding y value comes. So negative 3 comma 1 is a point, negative 2 comma 1 is another point, negative 1, 0 versus the y, 1 versus the 0. Every point came from equation. That was the original equation. For every value of x, there is a y value. We have to find the f inverse of x. So we know we switch x and y. So all we have to do is, we don't need the equation for that. All we have to do is switch the x and y. The inverse is done. So it's negative 3 comma 1. Instead of that, it's going to be just 1 comma negative 3. Next point, negative 2 comma 1 is going to be the 1 comma negative 2. Basically, the y is taking place of the x and the x is taking place of the y. They are switching. And the third point, negative 1 comma 1 is 1 comma the negative 1. Just switch the x and y value. That's it. 0 comma 3 is going to be 3 comma 0. And the last one is 1 comma 0 is going to be 0 comma 1. So x and y, they have switched. And that's it. That set of points was the original function. And the inverse set of points, the y and x, they got switched. And the answer is done.